let's get started. My name's Eric, and I do other things now, but I taught astronomy and physics for a long time, and mostly in Seattle. We've got a astronomy presentation for you. We're going to take you on a tour of the solar system and the planets and the moons that we have the best pictures of, and tell you about them. The program's going to last about an hour. I know there's a lot of younger folks here. If you need to bail, please supervise the kids leaving. There are some wires around, and look around because it's going to get darker, and we don't want you tripping over anything and falling into a blackberry patch. You're not going to like that here in August. This dish that we have in front here, the last time we were here on Camino Island doing this a similar program, we brought about an 80-pound fiberglass satellite dish of the same shape, and my friend Dan and I, Dan is here now. We're sitting over a beer, and he said, I think there's a better way to do that. And do you want to say a couple paragraphs about this?
Well, amazingly, this weighs about 8 pounds, and it's 10 feet wide. And I was very involved in the outdoor things and outdoor retail, and even in that whole world of that stuff. I said, I think we can use tent poles and materials, like some of the dome tents use, but we we went so some of that, but it was really fun. The fabric is actually from Hollywood. It's a projection fabric, but the whole thing now packs up into a small, easy to carry duffel bag, and we're hoping that we can. It actually works very well as a planetarium as well as a projection screen. But you can also just roam the stars in it as you would, and you don't have to look up. Don't get the stiff neck. So we're hoping to bring this to schools and maybe other places. We have smaller ones. We could make one twice this big pretty easily, and so that's. But the other thing about it is roughly a parabolic curve, and if you look carefully, I think tonight, at times you'll see, even though we're using a very single projector on that screen, it looks three-dimensional, and it evokes a three-dimensional illusion in a very simple way, not like these very expensive, things that you see. So hopefully we can bring this to the classrooms.
And here's Rob. He ran away just as we were about to start, which gave me pause. But here he's back. Rob is the last time we were here, I think Rob actually did this live, but this is a pre-recorded program. But he's got a 6-channel amplifier, and you want to say a little bit about the sounds people are going to hear?
Sure. Sorry, I needed a quick drink of water.
He's been working hard.
I do abstract photography, and I'm a composer and performer. For the last 20-some years, I've been doing live acoustic kind of dark ambient music and surround sound with projection. When I perform, and when we played here several years ago, and then at Kama Beach about 2 years ago, I did the soundtrack live, and it's all acoustic instruments, and I loop and layer sounds. I slow them down. For this one, it's just recorded, right? My life has gotten crazy, and I haven't had time to rehearse, and so we're using a recording, but this is all the original sounds. They're all acoustic sounds that have been slowed down and slightly processed and layered. Things like, starts off with bowed cymbals. There are a variety of wind instruments. There are sound toys. Toward the end, there's a cello. Lots of sound toys, some small hand percussion, and almost all of it is slowed down to make it kind of deeper and more textural and a little more mysterious sounding. Often it runs into a reverb. And this is going into a surround system, so the sounds will be slowly circling the audience. And that's how I normally perform. Eric gave me a list of the planets and moons. I did some research on them. I tried to come up, I do abstract photography and video, and I tried to come up with images and sounds that I kind of related somehow to the atmosphere or to the surfaces of these objects. So, I mean, it's abstract, it's not, I mean, I shot all of these with my iPhone. It's not, you know, I'm not on other planets, I'm not an astronomer. I don't have access to actual surface stuff, but this was my interpretation of some of these objects and their atmospheres and their surfaces, and you know, dry or wet or whatever, cloudy. Anyways, so that's what you'll be hearing.
All right, so let's go on a tour of the solar system. We're going to go through this, and I sort of have a prepared things I'm going to say. If you have questions, I'd ask that you hold them or ask someone else. I'd be delighted to talk to anybody for as long as you want to stay afterwards and answer questions. But since it's all sort of timed out, I can't really take questions while we're up and running.
But we are happy to have Eric answer questions afterward. That's, yeah.
Yeah. One thing I would like you to pay attention to is we have only scratched the surface of what's out there. It's like we've looked at one drop of water in the ocean. It's such a vast world, but when you see all these things, look at how different every one of these objects is, and they all have a unique history and story, just like each of us. And the other thing I'd like you to keep in mind, if you are 5 years old, then during your lifetime, more has been learned about these places than in the rest of human history put together, just in the last 5 years. It's an amazing time of discovery that we're on. And it might also seem like a really stupid time to some of us, but it is also an amazing era of discovery. So with that, let's back out of this. Oop. Hang on, Rob.
Actually, you can start because I've already started the process.
Okay. Let me get to my playlist, and away we go. Here's the sun. The sun is just a star like so many others. It's one of billions of stars. A nearly perfect sphere of hot plasma, heated to incandescence by nuclear fusion reactions in its core, radiating its energy mainly as visible light, ultraviolet light, and infrared radiation. It is by far the most important source of energy for life on Earth. Its diameter is about 1.39 million kilometers, or about 110 times that of the Earth. But its mass is about 330,000 times that of the Earth. The sun is really the only thing that counts in the solar system. It is about 99.86% of the total mass of the solar system. Most of it, 3/4, is hydrogen. The rest is mostly helium, and then there's some other stuff: iron, oxygen, carbon, neon. We call it a G-type main sequence star based on its spectral class. It's sometimes referred to as a yellow dwarf because it's a relatively small star and its light is closer to yellow than white. We think it formed approximately 4.6 billion years ago from the gravitational collapse of dust and gas within a region of a large cloud. Most of this matter gathered in the center because of gravity, and the rest flattened into an orbiting disk that became the solar system. The central mass became so hot and dense that eventually, in the center, it had initiated nuclear fusion in its core. All stars do this. They are simple beasts. The sun's core fuses about 600 million tons of hydrogen into helium every second, converting 4 million tons of matter into energy every second as a result. This energy can take about 15,000 years to escape the core. Sometime, long time in the future, when the hydrogen is mostly used up, its core is going to actually get denser, and the temperature will get higher. The outer layers will expand, eventually transforming the sun into a red giant. The sun at that point will get larger and larger, and it will engulf Mercury and Venus and get pretty close to the Earth, and it will make the Earth so hot everything on the Earth will perish. That's about 5 billion years from now, so set your watches. After this, the outer layers will get shed, and it will become a dense type of cooling star known as a white dwarf. It no longer produce energy by fusion, but it will still glow and give off heat from its previous fusion reactions. Anybody getting the sun coming out at you? Yeah. And to be clear, the dish actually goes in about 2 feet from the edges. Dan, do you think the sun is in focus exactly? If you feel like it, feel free to
Okay.
do a little focus. This is Mercury. You might have thought it was the Earth's moon, and it really looks a lot like the moon, but it's very, very, very different. It's always close to the sun, and when you see it, it will be close to the sun either just before sunrise or just after sunset, depending on its position. The earliest known recorded observations of Mercury are from the Mul-Apen tablets. These observations were most likely made by an Assyrian astronomer around the 14th century BC. That's, give or take, 3,400 years ago. The cuneiform name used to designate Mercury on the Mul-Apen tablets is transcribed as Udu Idim Gu, the jumping planet, because it moves fast, it's close to the sun. The Babylonians called the planet Nabu, the messenger to the gods in their mythology. Its rotation is locked in a 3-to-2 resonance with its orbit around the sun, like the relationship between a musical note and its fifth. Mercury is still shrinking and tectonically active. Like Earth, Mercury has a dense iron-rich core and a strong planetary magnetic field. The Mariner 10 spacecraft flew by Mercury in 1974 when I was 16. Messenger orbited Mercury 4,000 times before crashing on it in 2015. Among many discoveries, Messenger discovered many kilotons of water ice in permanently shadowed craters near Mercury's North Pole. Mercury's orbit precesses or changes about 1.5 degrees per century, and this defied explanation until Albert Einstein proposed that the sun's gravitation curved space-time to create the observed slow change. Anybody know what's next?
Venus.
Venus, you are correct. If I had some homemade ice cream, you'd get some.
Melted.
So These pictures all come out of a piece of software called Worldwide Telescope, which is free. But we didn't have these pictures 10 years ago.
Worldwide telescope.
Worldwide Telescope, yeah, it's sort of a free thing from Microsoft.
It looks like the moon.
It really looks a
And
lot
why,
like the moon.
why, Mr. Moose?
Well, there's the craters.
In lack of an atmosphere to protect the surface, perhaps?
Yeah, and this is sort of a when we get to the moon, we'll talk about it a little bit more, but Mercury probably isn't as bright as this. It's about as bright as a blacktop parking lot, but it gets a lot of sun. Sometime we're going to get over to Venus here.
But does our atmosphere protect us to some degree?
Well, there's that. And the sun, of course, tends to pull stuff in towards it. So
right.
if you're near the sun, you're going to get crashed. This is Venus. This is not the view you'd get from a telescope, because Venus is perpetually covered in a very thick cloud layer. This is a radar image that sees through the clouds. Venus is named after the Roman goddess of love and beauty. Venus is the brightest natural object in the Earth's night sky after the moon. Venus can even cast shadows and can be, on rare occasions, if you look in the right place, visible during the day, a star during the day. Of course, it's not a star, but it seems that way. Venus is inside the Earth's orbit, so it doesn't ever get very far from the sun. That's why we either call it the morning star or the evening star. It's you'll see it in the west after dusk, or rising in the east just before dawn. In some ways, Venus is very similar to the Earth. It's roughly the same size, and we think it has volcanoes, possibly even plate tectonics, but in other ways it's extremely different. It has the densest atmosphere of the 4 terrestrial or rocky planets, like the one we live on, and its atmosphere is more than 96% carbon dioxide. What is carbon dioxide? Why are we worried about carbon dioxide here? Well, global warming, yeah, trapping the sun's heat. And Venus has the hottest surface of any planet in the solar system, with an average temperature of about 700 degrees. The Russians landed a probe there in the 70s, and it lasted about a half an hour before it burned up and the heat and the acid got to it. The atmospheric pressure at the planet's surface is about 92 times the sea level pressure on Earth, or like you would experience if you were about a kilometer underwater. Very heavy atmosphere. Radar observations in the 1970s started to reveal the details of the surface for the first time. Pulses of radio waves were beamed at the planet using the giant radio telescope at the Arecibo Observatory in Puerto Rico. Any of you ever see that in one of the James Bond movies? He has a fight there. I've been there. Sadly, that is now kaput. It was heavily damaged during Hurricane Maria, but I actually saw the antenna they used to see to the surface of Venus for the first time there in the museum.
Was it like LiDAR that they used?
There are not, at that time there was no LiDAR thing, but now, yeah, it's we have great images of the surface. If you're familiar with the volcano Kilauea, that is, or maybe you've been there, it's very sort of wide, very runny lava, and there's a lava lake there, and we believe we've found many of those type of features on Venus. And there are some craters, but notice there are many fewer craters, indicating the surface is relatively new. This is where we live, and it's the nicest planet by far of all the ones we're going to look at. I am all for exploring space, and I think you can house homeless people and feed hungry people and still make discoveries. I don't think it has to be one or the other, but going to Mars, as I used to say to students, the best day on Mars is worse than the worst day in the worst place on Earth. And I've been to the South Pole, and that's pretty bad, and it's way nicer than anywhere on Mars. We've got this beautiful atmosphere that we live under, and we're like fish swimming around in the atmosphere. If you go straight up, how far is it till there's not enough air to breathe? It's just 5, 6, 7 miles, and that's it. We live in this tiny skin of beautiful air. How do we get to this? I guess we're on the moon. Okay. This is our moon. We've been there. Such an amazing, cool place. We think most of these craters are really old. We think there was an era in the early solar system where things started to settle down, but then they didn't. If you ever had a bad tire on your car, maybe you know what wobbling looks like. And there was a wobble, and that's when most of these craters hit. It pulls on the Earth. There's no other pair of objects in the solar system that are as closely matched as the moon and the Earth. And the moon's gravitational influence makes each day on the Earth a little bit longer. And of course, it pulls on the oceans and makes the tides. The best idea for how the moon came to be is there was an impact between our planet and a Mars-sized body that some scientists call Theia. And they smashed together, and the moon formed out of the debris that was ejected and didn't come back to form the Earth. The near side of the moon, which we're starting to see now, is marked by these dark volcanic maria. Early astronomers called these seas. Although of course they don't have water, but you could see how somebody might think that if they didn't know. And these date from about 3 billion years old. Anybody know where the first Apollo astronauts landed? They landed near one of these, and it has a beautiful poetic name. Yeah, what mare or sea did they land near? The Sea of Tranquility. And there's each one of these big sort of flat, dark lava areas has a particular name.
Is there any lava under the surface?
The moon does not seem to be tectonically active. There are, you ever been in one of the lava tubes in Oregon? Or we have some in Washington even. There are some of those on the moon, but very few places in the solar system seem to be presently active. I mean, the Earth is just crazy. I think right now there's something like 50 volcanoes that are doing something. And the moon has, it's relatively pretty boring. I think that was a moon moth.
Right.
God, yeah.
Luna moth.
Yeah.
So tell us about the dark side of the moon. Oh, too late. Next one.
I will not, because we're going to look at Mars.
That's okay. Yeah. I was trying to fill in.
So this is Mars. People think of it as a place to go to colonize. The atmosphere on Mars is about 1/100th that of the Earth. If you landed there, without a spacesuit, you would be dead within seconds after trying to take your first breath. There's nothing there to breathe. What atmosphere there is mostly carbon dioxide. The North Polar Cap that we're seeing right now is mostly frozen carbon dioxide, dry ice with some water ice mixed in. But it's still a really interesting place. There is frozen water on Mars, aplenty. There was liquid water in the past. There is almost certainly liquid water under the surface. And I think, just my personal opinion, we're going to find life there. Because life is really good at staying alive and being persistent. Not book reading, music listening, extraterrestrials, but maybe bacteria. Mars is so small, its gravity is only about 1/3 of that of the Earth. So I would weigh about 100 pounds and I could dunk. Mars has the largest volcano in the solar system we know of, Olympus Mons, and the deepest canyon that we know of anywhere, Valle Marineris. It's amazing to think, there's the Valle Marineris, this big long slash there, this huge canyon system about the size of the United States, west and east. The largest volcano in the solar system is coming up. Those other round ones are volcanoes as well. But Mars doesn't seem to have continents that move around. It never seemed to have generated that level of activity. It's amazing to think that right now we have robots that are driving around, taking samples, doing chemistry, and sending back information to us. It's phenomenal. Never mind that little helicopter that they were flying around. And the helicopter, I think they were gonna, we're gonna try flying it for like 5 days, and it lasted months. They got so much work out of it. It was an amazing achievement. Curiosity right now, the Curiosity rover is exploring Gale Crater, which is a really interesting asteroid crater, but it's clear that running water at one time, like 1 billion years ago or more, came into the crater and made a river delta and probably filled up the crater with a shallow lake. And it was thought, there's a good place to go look for life. So that's what's going on there. There's water on Mars. There's resources. There is no atmosphere. If people go to Mars to live, it might well be a one-way trip. But if they go there to live, they will probably live underground. There's no atmosphere to protect from the sun's radiation or the radiation coming from the rest of the universe. So, not a thrilling spot. This, aside from the sun, I like to call this the 600-pound gorilla in the solar system. This is Jupiter, the largest planet by far in the solar system. We have a probe around Jupiter right now that is returning just amazing pictures of these gas clouds. And these gas clouds go down for hundreds and hundreds of miles. We actually dropped a parachute probe down in, and it lasted a few hours, till the pressure got so much it was destroyed, and that was completely expected. Coming up right now, that thing that looks like an eyeball is the giant red spot. Some of the first astronomers hundreds of years ago spotted this. It is a storm, a cyclone, a hurricane, if you will, that has been going on for hundreds of years. And it changes over time. It gets bigger or smaller. Just an amazing event. And there are smaller versions of that taking place elsewhere on Jupiter.
How far away is the light from Jupiter?
I'm not remembering off the top of my head. Light from the sun takes 8 minutes to reach us, and I think Jupiter is farther away than that.
Okay.
So, plenty far. If you want to send a mission to Jupiter, it involves, well, years of planning. But then you've launched your probe, and generally they send them past a couple of the inner planets to pick up speed in a maneuver called slingshot. So you get your probe launched, and you're going to get to Jupiter maybe 2 or 3 years later, and that's the express train. Jupiter has, at last count, more than 90 moons, and probably there's lots of small moons left to be discovered. Have any of you ever seen Jupiter through a telescope? It is a spectacular sight. You can see, even in a small telescope, even in binoculars, if they're pretty good, on a clear night, you can see some of these bands. The other thing you will see is 4 bright dots. A guy named Galileo, hundreds of years ago, pointed a telescope at Jupiter for the first time, as far as we know, and he saw these 4 bright dots, and he looked at them night after night. We still have his drawings. And he realized that they were orbiting Jupiter, and it was an amazing discovery. And we're going to tour those 4 large, called Galilean moons, after Galileo, who discovered them. We still have his original notebooks. Really important discovery in the history of human consciousness. The Earth is not the center of everything. We used to think that. Some people still think that about themselves. So Jupiter kind of determines a whole lot of other things that happen in the solar system. It has a lot of gravitational attraction. I'm trying to remember when this was. I believe it was the mid-90s. A comet got too near Jupiter. Jupiter's gravity broke it into pieces, and the pieces crashed into Jupiter, and we saw all this. There's pictures of it. This is the first of the Galilean moons of Jupiter. This is called Io. And if you want to read a racy story, read about Zeus and his wife Hera and Io. Things did not work out well for Io in the end. Hera was very angry. Io is close to Jupiter, and that means it gets squeezed and pulled, and it's hot because of that. Just like if you bend a paperclip back and forth, it gets hot. That's Io. It is the most volcanic body in the solar system. None of those things that you see are craters. They are yellow sulfur lava flows, and the whole surface of Io is really very new, hundreds or thousands of years at most. These volcanoes are constantly erupting. In fact, Io puts out so much dust, volcanic dust, that there's dust all the way between Io and Jupiter, and sometimes there are lightning bolts that cross between Jupiter and go over to Io through the dust. Imagine a lightning bolt going from the Earth to the moon. That's the kind of distance we're talking about. So it's a super interesting planet. Would you want to visit there and walk around? No. No, you would not. Very exciting, but very inhospitable. And we've seen these volcanoes erupting. Dan's focusing a little bit. Thank you, Dan. So each of those black dots represents a different volcano on Io. But it is a beautiful yellow color, and there's really nothing else like it in the solar system. And I hope you're already getting an idea that all of these objects, and this holds true even for the smallest moons, each one is got a history that can be kind of unlocked through study.
What would the size comparison of that moon be?
Give or take about the size of our moon.
Okay.
These 4 Galilean moons, at least Ganymede is significantly larger than our moon. But we'll get to that in a moment. I can tell because Rob's music theme is changing.
We're just doing
Question.
Io now.
Are any of the moons larger than Earth?
No. Is this the Io music? Huh. Explain that.
Earth was short.
Okay.
Dave is short. Somehow we're trying to
Somehow,
fast forward.
okay.
How does the red spot go on for so long?
We're not really very clear about that, but storms require energy, and they represent energy moving around. Jupiter has this enormous mass, and the clouds get denser and denser and denser till it's liquid. It might even have a metallic core. We don't really know, but Jupiter emits a lot of radio waves, for example. It's a very active energy emitter. So there's a lot of energy going on there. Some people have even described Jupiter as a sort of a star, a wannabe star that never quite got enough hydrogen to get going with fusion, but it got pretty close. This is Callisto. It's the second largest moon of Jupiter, and it has the oldest and most heavily cratered surface in the entire solar system. That's the oldest. It shows no evidence of subsurface processes such as plate tectonics or volcanism. No signs that geologic activity of any kind has ever occurred. And we think the surface pretty much looks that way because it's just been hammered by meteorites hitting it from as early as the solar system formed. So it's about the same size as Mercury, but it's only about 1/3 as heavy, which is really interesting. So it's if Mercury is a rock, this is more like a marshmallow. Very, very lightweight. We think, based on density measurements, this is one of the Jupiter's moons that might have an ocean under the surface. And astronomers and scientists, what do we look for when we have an ocean somewhere in the universe? What are we hoping is there? Life. We'd like to meet some life so we can take their stuff. So this is one possibility for where we can look for life, but there are better possibilities, and we'll get to a really exciting one next.
How would people guess there's an ocean under this?
So we have ways of using radar to penetrate the surface. That has limitations. You can actually look at how an object like this gets pulled on by the gravity of Jupiter, and in fact even the other moons, and how it's affected. Even if you're on a little merry-go-round at the park, and if you move to the center, the rotation is different. Where you put your mass is different. So by studying the movement of the planet, we can get some ideas about that. The best way, and we've done this on the moon, is to put, and Mars actually, is to, and Earth of course, is to set off a small explosive charge and listen to how the wave travels through the rock or water, or on Earth we're very interested of course in finding oil that way.
Okay.
All those, the waves behave differently in all those materials, and you can figure it out. Humans are very clever at figuring stuff out, except how to live with each other. This may be a good place for a base for the outer solar system, because to explore the outer solar system, because it's so stable. But those are brave people that take on that job. This is the moon next to Callisto. This is Europa, and we have a probe underway that's going to Europa. We think this, what we're looking at here, is like the frozen surface of the Arctic Ocean in winter, or lake. Which lake freezes over most readily? Erie, maybe? Ontario, maybe none of it.
Erie.
A far northern lake. The ice might be 30 miles thick. And the gig here is put a lander down on the surface and then have a probe that melts its way all the way through to the liquid underneath. Of course, what's in that ocean underneath? Scary, scary monsters that have been waiting for humans and want to eat them. That's all they think about. They've been waiting for billions of years for humans to show up so they can do scary things. Or not. Obviously no light gets through that ice, so there can't be photosynthesis, but there are plenty of organisms on Earth. None of them are terribly complicated, but plenty of organisms on Earth that make their living not off photosynthesis and the sun's energy, but off of hydrothermal vents and volcanism. So those cracks are all cracks in the ice, represent the ice on the surface being reformed. We think sometimes even it's possible that there are faults in the ice and liquid comes out and covers up some of the surface and freezes. Europa doesn't have much atmosphere, but it's got liquid water. It's a very exciting place to think of looking for life. By the way, you see a strip on Europa here that seems to be more detailed. Our work on these places is so new that we don't necessarily have good pictures of the entire surface of some of these objects. That's where we are. We've got some fuzzy pictures and some good pictures, and we put them together. Whenever you see a picture of one of these objects, it's been heavily processed. And that's not a bad thing. It's not like AI making up some stupid made up stuff. It's the best that people can do to put together the images that we have, so that we can try to learn about them. Such a fabulous moon, though. So this is a place we are also likely to discover life. The trick with a probe like that, though, you melt your way through. The probe better be completely sterile and better not have an earth bacteria on it, or you have contaminated your results. It's very tricky and even an ethical problem to go to a place like this and bring earth life to it. Earth is just crawling with bacteria. Did you know there's more cells living on you and in you than your own cells? You're basically just a bus carrying around a whole community of stuff. This is the last of Jupiter's moons that we'll visit. This is Ganymede, particularly beautiful name, I think. The largest and most massive of the solar system's moons. It's the 9th largest object in the solar system, but it has no atmosphere. It's made of rock, but it's also made of water. We think it probably has an iron-rich core, but it probably also has an underground or undersurface ocean, and that might have life too. It has a thin atmosphere that includes oxygen, and as we saw with Mercury earlier, Ganymede has sort of makes a musical chord with Europa and Io. For every orbit of Ganymede, Europa orbits twice, and Io orbits 4 times. So they kind of work together. Their timing is like clockwork. In fact, after they were discovered, sailors used telescopes, and they would look at the Galilean moons as a way of figuring out what time it was. Because that turns out to be not so easy on an old primitive sailing ship. I like this idea. In 2014, scientists studying Ganymede thought that it might actually have several layers of ocean separated by layers of ice or rock, sort of like a tiramisu. And now that we think about that, let's imagine different kinds of aliens living on each layer, like in a condominium. Does this look sort of like the Earth's moon? Yeah, but is it different? Completely. All of these are very, very different from each other. We've got 3 to go. You've been very patient. The solar system appreciates your work.
Great sound.
Was that a bat? I think it might have been. Did you just see the bat go across the screen? This is Saturn. I had to make a decision about how to show this. I decided to mostly concentrate on the planet and let the rings spill off the edges. Saturn is a lot like Jupiter, but it's also a lot different. It's somewhat smaller, and it's got this incredible ring system. The first person to see the rings through a telescope was Galileo. He had no idea what he was looking at. He thought it was a planet with ears. And he wasn't even very clear what a planet was exactly. It took another 150 years before another person realized what they were looking at. And in fact, the rings tilt as Saturn goes around the sun compared to us. So it helps to have the perspective of time, like decades of observing, to help figure out it's not ears but it's rings, because they really are a most improbable structure. They're not very thick, probably 10 miles thick, and they're composed of chunks of dust, gas, ice, possibly house-sized pieces, but also ice cube-sized pieces, and lots of even smaller pieces. Jupiter has rings also, and so do Uranus and Neptune, but none of them are anything like as spectacular as Saturn's. And we think a little bit that's an accident of history that we're here to see these. These probably are not super stable and don't last a long time. They probably represent one or more objects kind of being crushed by the weight of the planet, the gravitational pull of the planet, and torn apart into pieces and orbiting Saturn. But they're probably not very stable. And because my animation is going fairly quick, you can actually see the rings coming, and pretty soon they're going to get edge on to us and they'll be barely visible. That's part of how we know they're so thin. But it is a spectacular thing to look at. And I, for one, am going there for Christmas. I'm not going to land or anything because it's a gas giant. I'm not going to walk on the rings because they're not solid. But I'm just going to go and orbit around it and look out the window and drink a coffee and admire its beauty. You'll notice the gas clouds aren't nearly as bright and contrasty as Jupiter's. It's a little bit duller in that way. Saturn is sort of like the little brother of Jupiter. It's bigger than any other planet except for Jupiter. It's got its own storms. It's got some really interesting storms at its North Pole that create these hexagonal structures in the gas clouds that we don't understand. Any of you ever see the great Stanley Kubrick movie 2001? We go to Saturn because there's a moon that has a monolith on it, as it turns out. This is Uranus, second to the last real planet. It's tilted on its side. That's really odd. We think all of the solar system formed out of a cloud of dust and gas that collapsed, most of it, the material ended up in the sun, and the rest sort of made its own little spin-ups and condensed together, and all of them point, their axis of spin all points essentially up. I mean, the Earth is tilted 23 degrees, probably because something hit it. Mars is tilted a little bit more, probably because something hit it. And Uranus is tilted almost completely over on its side, probably because something really clobbered it. But we really don't know. And like Jupiter, like Saturn, when we look at it, all we're looking at is the top surface of a cloud layer that gets deeper and deeper and thicker, mile after mile, hundreds of miles down. And it's really cold. Sometimes we refer to these as ice giants. Like Jupiter and Saturn, it's mostly made of hydrogen and helium, but Uranus and the next planet we'll see, Neptune, also contain some liquid stuff and even ice like water and ammonia, methane ice. It's got a ring system of Of course, the rings are tilted and along Uranus's equator. So if we could see the rings in this animation, they would be sort of slicing straight up and down right now. We've been there, but not very often. So we don't know that much about it. We do know that wind speeds have approached about 400 miles an hour, if I get my facts right. And what causes the seasons on the Earth? Well, it's the tilt of the axis and whether we're pointed towards or away. If the planet's on its side, it has some very, very weird seasons. It's a very odd kind of place. It's got a lot of moons. So what's left? Neptune, and we're gonna do Pluto too. And the farther out these planets go, the less time ago it was that we discovered them. Uranus, I think, was discovered by Herschel, wasn't it?
Yes, you can
Yeah.
see it.
About, what, 200 years ago?
Yep.
Yeah. Neptune much more recently. And
I've seen it with binoculars, actually.
this is Neptune. It is not visible to the unaided eye in any way. It's just so far away. It's very large. It's larger in size than Uranus, but it is just too far away to be seen by the naked eye. Neptune was found not by looking at the sky or looking through telescopes, but by looking at other objects like Uranus and seeing that it seemed to slow down and speed up in some weird way, as if something was pulling on it. And if you're really smart with math, you can, not me, thank you. If you're really smart with math, you can figure out where the pull's coming from and tell somebody with a good telescope to look over there. And that's how Neptune was discovered. It was pretty clever. Neptune's outer atmosphere, what we're looking at here, the tops of the clouds, one of the coldest places in the solar system. Temperatures at the cloud tops are about roughly 200 degrees below zero. Very unpleasant place.
Is it colder than in the middle of space?
In general, deep empty space is about 4 Kelvin or 4 degrees above absolute zero.
Oh.
So it's warmer than that.
Yeah.
So you go really cold, space travelers go here to warm up, but it's not very effective.
Where are these clouds low since they don't freeze?
Well, hydrogen, helium, water ice, ammonia, methane. On Earth, we're used to thinking of there being a very clear division between gas, and then you cool down a gas, and now it turns to a liquid. We see water do this all the time, and it rains. And if you cool down the water even more, it gets solid at very strict temperatures. But in these kind of clouds, you go into the top, and it might be gas, and you go down farther, and it's still kind of gas, and after a while, this is if you could live and actually tell about the experience later, you realize I'm in a liquid, but there wasn't any surface, like the surface of Puget Sound. It just got thicker and thicker until it behaves like a liquid. We think that all of those craters in the Moon and Mercury and Mars and Callisto that we saw may have occurred during a rearrangement of the solar system when Jupiter made Uranus and Neptune change places, and they may have moved from closer in the solar system to further out, but there was a big disturbance about 1 billion years in called the late heavy bombardment, and it let a lot of rocks going every which way, and a lot of them made craters. So there's a lot about this we really don't know. There's a lot left to be discovered. And it's very easy, if you're interested in these kind of things, to think, oh, I wish I'd lived 200 years ago, because then they were discovering just the easy stuff, and I could have done that. I could have figured out there was gravity. But from wherever people stand, the stuff that's not figured out yet is very challenging. This is Pluto. We've been there. It took a long time to get there, a decade, give or take. And did we go in orbit once we got to Pluto? Oh no. We went by like a car going by the Tulalip Casino at 80 miles an hour on the freeway, take your pictures, and we're out of here. So we were very happy to get photos. We have even better photos now that with processing, but this is what I have. Super interesting place. It's got an atmosphere. The atmosphere sometimes freezes, and then it's got no atmosphere, and then the atmosphere thaws out and turns to gas and comes back. But it is super cold. It is super far away. And we should talk about Pluto being demoted.
Yeah. So sad.
You're angry about that?
Slightly.
So
It's like,
no
these
tears, no tears, because Pluto doesn't care. Pluto is still just doing its Pluto thing. But
was like,
when Jupiter has a moon around it, Jupiter pulls on the moon and makes it orbit, but the moon also pulls on Jupiter. But it doesn't pull on Jupiter enough to do what Pluto and its largest moon, Charon, do, which is they go around each other, kind of like this. So it's not one orbiting another. It's, yes, that kind of a thing. And that's one of the reasons it got demoted. There are, we're finding out there are lots and lots and lots of other objects, these so-called Kuiper belt objects that are more similar to Pluto. It's a really interesting object. It's very, very different from Uranus and Neptune, but there's a lot of things that are sort of like this. But again, each one is different. Some of them are on very odd orbits. Another reason Pluto got demoted, its orbit actually gets closer to the sun than Neptune sometimes. It's also very tilted. And these were all presented in court, and Pluto was demoted. But there it is.
Public defender.
Yeah, it needed a better attorney. But it's actually very typical in science. You know, you land on the Earth, you start looking around. Oh, trees, and then you realize, okay, well that tree is sort of like that tree, but it's not like that other maple tree at all. So now we've got different categories, and we make more and more categories to help our understanding and of where these things come from. When I look look at Pluto, I always think of this book by a science fiction author I liked as a kid. Have spacesuit, will travel. He ends up on Pluto trying to escape from some aliens, and he has a spacesuit, and he tries to run outside and radio for help, but it's super cold, and it does not go well. So that is our presentation. Thank you to Rob for the music. Thank you to Dan for logistics and the dish. I thought I'll just stop that and open up a free software that I have here called Stellarium, and it'll take a few moments to open up, but